So we are going to work on reviewing for our second exam. And our first question, this is for business math, we are going to graph the function y is equal to 5x. So this is a exponential function. So again, we're looking at y equals 5 raised to the x power. So we still are going to pick some values for x to find out what y will equal. So I'm going to make a t-chart for my x and my y, and I'm going to pick some simple numbers for x. I'm going to get -1, 0, and 1. So if we look at 5 to the -1, well, the negative exponent tells us we can actually move this down into the denominator, so it'll be 1 over 5 to the first power, which is just 1/5. And then 5 to the 0, anything to the 0 power equals 1. And then 5 to the first power will just be 5. Now you could do some other numbers, but these will work for what we need. So we need like 5 hash marks for our y values and not a whole lot for our x. So we'll have 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5. We can even put a 6th one there. So 1/5 is going to be close to our x-axis. So it'll be like right here. We're just doing a sketch. It doesn't have to be perfect. And then 0, 1 will be right there. And then 1 to the 5. And you're going to graph this. There's basically like an asymptote that happens here, a horizontal one. So we're just going to kind of not cross that line and just kind of sketch the graph. So just kind of sketch it. It's a sketch. It's not a, oh my gosh, this is perfect. So that's all you have to do for that one. All right, let's look at our next problem. So our next problem, we have g of x is equal to 4 to the x minus 5, and then -3, and f of x is equal to 4 to the x. And it tells us to describe verbally the transformation that can be used to obtain the graph of g from the graph of f. So this is our base function of 4 to the x. What is changing in our graph here? So this part up here will tell you if it's going left or right. It's the horizontal transformation. Will the graph move to the left or to the right? And with the -5, it'll actually go to the right. If it was +5, it would go to the left. So we know that it's going to go right 5, and then the -3 tells us it will go down. If it was +3, it would go up. So right 5, down 3 is how it will change. And that's all I'm looking for, is for you to tell me what is changing. All right, number 3. So for number 3, we are solving the equation e to the 5x minus 9 minus e equal to 0. And it's just telling us to solve it. So what we're going to do is add this e to the other side and get e to the 5x minus 9 is equal to e. So remember, e is like a number between 2 and 3, because 2 squared is 4, 3 squared is 9, and e squared is 7 point something. And so it's an actual number. And we know that if it doesn't have an exponent, we know it's to the first power. So if e to this power equals e to that power, we know that the powers have to be equal to each other. So 5x minus 9 has to be equal to 1. Let's add our 9 over. We get 5x equal to 10. Divide by 5. X will be equal to 2. And that's our answer. All right, next question, number 4. On 4, we're asked to rewrite the log of base 7 of 343 equal to 3 to rewrite this in exponential form. So the base will stay in the same place, so we bring down the base. The 343 and the 3, visually they look like they swap places. That's not what's happening mathematically, but visually it looks like they will swap places. So you end up with 7 to the third equals 343. And that's all there is. Number 5, we are asked to rewrite the equation in equivalent logarithmic form. So we have 8 squared equals 64, and we want to change this to look like it has a log. So again, the base will stay in the same place, as in it'll become log base 8, and then the 64 and the 2 will change places. So 64 is equal to 2. All right, so that's changing from a log to an exponential and an exponential to a log. All right, our next question, number 6, we are going to evaluate without using a calculator. So this, if we have e to the ln of 7x, this is where we have to understand our logarithmic rules and properties. And remember, ln has the base of e, and one of our properties stated that if we have e raised to the power of an ln, then the final answer is just whatever is left in that exponent, which in this case would be 7x. This one is to just tell you need to look at your log rules and make sure you understand the different ones that are listed in the log rules. All right, number 7. We're going to use the properties of logs to simplify the logarithmic expression. So we have 2 log base of 4 to the x plus 5 log base 4 y minus 7 log base 4z. So the first thing I notice is they're all the same base, so that means I can combine them together. All of the numbers in front are actually the exponents. We're going to move the exponents back up. So log base 4x squared plus log base 4y to the 5th minus log base 4z to the 7th. So I've moved all of our numbers that are in front of the log back into the exponents. Now addition, remember addition becomes the multiplication and subtraction becomes division. So the first thing we'll do is combine the multiplication. So we'll have log base 4 x squared times y to the 5th minus log base 4 z to the 7th. And then the subtraction becomes division. So we'll have log base 4 x squared y to the 5th divided by z to the 7th. And that's your final answer. Now, I'm okay on this particular problem. If you can see how to go from here to here in one step, you can do that, because I can do that without having to draw it all out. I can put all that back together and so forth. So if you want to just do from here to here, I'm okay with that. Just be careful and make sure you put everybody in the right spot. All right, number 8. We are going to use the properties of logs to solve. So we have log 3 plus log of x plus 2 equal to log 15. So we're going to use our properties of log again. Addition means multiplication. So we have the log of 3 times x plus 2 equals the log of 15. So this is similar to when we solved for the e function earlier, where we had e to this power equaled e to that power, where the powers had to be the same. This is the same thing, type of situation. We have log of this equals log of that. And if they're equal, then this part here has to be equal to that part. Otherwise, they're not equivalent. So that tells us that we have 3 times x plus 2 has to be equal to 15 in order for these logs to be equal to each other. So let's go ahead and multiply this out. We'll have 3x plus 6 when we distribute to 3 is equal to 15. And we'll move our 6 over and get 3x is equal to 15 minus 6 will get us 9. Divide by 3, and x equals 3. The only thing you have to be aware of on these is that you don't get a negative value that would cause you to get a log of a negative number. Otherwise, you should be good. So x equals to 3 will be our answer. All right, our next problem, which is number 9. Number 9 says to use the properties of logs to solve. So we have 6 to the 3x is equal to 35. So here we have our variable is in our exponent. So in order to get that down, we're going to use our properties of logs. We're going to take the natural log of both sides. Then that can allow us to move our exponent out front. So 3x ln of 6 equals the ln of 35. Now I want to solve for x, so I'm going to divide both sides by everything that is not the x. So now x will be equal to the ln of 35 divided by 3 times the ln of 6. And then I can put that into my calculator. So I have the ln of 35, make sure you close the parenthesis on that, divided by 3 ln of 6. So let's try this again. So the ln of 35 divided by parentheses 3 ln of 6. There we go. We have to divide by everything. What happened was I didn't put the parentheses, so be careful about that. And so I divided by the 3 is what it did, and then it saw the multiplication and multiplied by the ln of 6. But you need to divide by the whole thing. So make sure you put that bottom part in parentheses. Otherwise, you don't get the same answer. So parentheses really do matter. So we're going to get 0.66. So make sure you do this part in parentheses. Otherwise, you will get a different answer. All right, let's go on to number 10. So for number 10, we are given log base 7 of x minus 5 equal to 2. And it says to solve it. Well, we're going to use our previous knowledge here and go to exponential form. So 7 squared equals x minus 5. 7 squared equals that. This is similar to what we did earlier, changing it from a log to an exponential form. 7 squared is 49. add the 5 over, and we get 54 is equal to x. And that's your answer. All right, number 11, we are given a word problem here. Suppose $6,000 is invested at 6.3% annual interest rate, compounded monthly. How much money will be in the account in 7 months? So on this one, it's compounded monthly, so that tells us that we have an n in our function, or an m, depending on how your formula is. We did the ones with the n's because that's what is in our book. So we've got that monthly part there. So we know that we're going to have a principal, we've got an interest rate, we've got amount of time, and we've got a compounded monthly. So this will be A equals P times 1 plus R over M raised to the M times T. Now you can write all of your parts off to the side, or you can just plug them into the formula. So A will be equal to the principal. The amount invested was $6,000 times 1 plus our rate was 6.3%, and we have to change 6.3% to a decimal, so it becomes 0.063. So 0.063 divided by compounded monthly. Monthly is 12, raised to the 12 times the amount of time. It's 7 months, and it needs to be in years, so you're going to put 7 out of 12 months. So 7 divided by 12, because 7 months, not a whole year, so put it out of the number of months. All right, so we've got 6,000 times 1 plus 0.063 divide by 12, close your parenthesis, and then raise it to 12 times 7 divided by 12. Of course, the 12 will cancel. And we get $6,224, because the 3 won't cause it to round up. And there's your final answer. All right, number 12. On number 12, it says, how many years will it take for an initial investment of $4,000 to grow to $12,000 with an interest rate of 7% compounded continuously? If you have continuously, that means you're using the E. And so this one will be A equals PE to the RT. So how much will be in the account? And we were told that the amount in the account to grow to 12,000. So we've got 12,000 is equal to the amount that we, the principal was 4,000, and interest rate of 7%. We're looking at how many years. So e to the 0.07, because 7% changed to a decimal becomes 0.07. And then we have our t. So we are looking to solve for the t that's in the exponent. So the first thing we're going to do is simplify this a little bit. We need to take the ln of e so that we can bring our exponent down. So I'm going to move the 4,000 away from the e, and you can simplify this down a little bit if you would like, because it'll make it easier. If you get to a whole number, it's okay. If not, then you can leave it at the ln of the thing. But since we have the zeros on top of each other, they will cancel, and 12 divided by 4 will get us 3. Will be equal to e to the 0.07 t. Now what I want to do is take the ln of both sides. So I have the ln of 3. The ln and e, they undo each other, so they will go away. And we're left with our exponent that could be brought out to the front. And so we have 0.07t. Now we're going to divide by 0.07. So now we have that t is equal to the ln of 3 divided by 0.07. And when we put that in our calculator, we will get 15.69. So it'll take a little over 15 years, not quite 16 years, to get to the $12,000 we're looking for. All right, number 13. On 13, Joe put $23,000 in a certificate of deposit that gained interest at a rate of 3.2%. How much interest did the account gain after 6 months? So now we have to look at what we are given. We're given the principal, we're given the rate, and we're given a time. We don't have a continuously, we don't have a monthly, we don't have any kind of compounded. So, and they're asking how much interest. If you're looking to find the interest, you're going to use I equals PRT, the simple interest formula. So I will be equal to, our principal is the amount of money that was put in, which is $23,000, times our rate. We were given 3.2%. It needs to change to a decimal, so 0.032. And then the time is 6 months out of 12. Again, it has to be in years. And we would put that all in the calculator with multiplication, and we get $368. That's how much interest we would gain in 6 months. All right, our next problem, number 14. On number 14, we have a loan of $4,000 was repaid at the end of 10 months with a check of $42.70. What annual rate of interest was charged? So in this case, we're looking for an R. We're looking for the rate. We're given a loan of $4,000, was repaid at the end of 10 months, so that's a time. So we're given a P, we're given a T. With a check for $42.70, that's the accumulated amount. So that would be the A. So we don't have an M, we don't have an E. So in this case, we're going to have the formula of A equals P times 1 plus RT, because we have an accumulated value, a principal, a rate, and a time. So to figure out which formula you need, you have to figure out what are you given, what are you looking for. The accumulated amount in the account is $42.70. The initial amount of the loan, which is the principal, was $4,000. We're looking for the rate, so we'll just leave the R sitting there. And we're given the T was 10 months. So again, it's going to be times 10 over 12. So I'm going to go ahead and distribute a little bit. So we'll have 4270 equals 4,000 times 1. 4,000 times our R times 10 over 12. Well, the 4,000 times 10 over 12 will get us 33.33. And now we're just doing a little bit addition and subtraction. So subtract the 4,000 from both sides. And we get 270 equals to our 33.33R. Divide by 33.33. And our R is now equal to that 270 divided by 33.33. And that'll get us 0.081, which will become 8.1%. So this would be our final answer. Since you're looking for the rate, you want to change it into a percentage. So we've had very similar problems. You're really going to have to look at what you're given and what you're not given to figure out which formula that you need to use. You will have a list of formulas provided. You just have to figure out which one it's looking for. All right, so how many years are required for an investment to double if it is appreciating at the rate of 4% compounded continuously? So continuously means we're going to have the formula with the E. So A equals PE to the RT. And it said that we're doubling. We weren't given a whole lot. We're given continuously 4% and then it doubled. Well, if the amount doubled and we originally put it in a P, then the doubled amount would be 2P. So 2P equals PE to the R of 0.04 times T. And we're looking for how many years? So we're going to divide by P on both sides and get 2 equal to E to the 0.04T. And we're going to do the same thing we did earlier. We're going to take the ln of both sides. So now we have the ln of 2 equal to 0.04T. Divide by 0.04 on both sides. And our T will be equal to the ln of 2 divided by 0.04, which will get us 17.33. So the amount of time it will take is a little over 17 years. All right, number 16. For number 16, what is the annual percentage yield for money invested at the rate of 7% quarterly and 8% continuously? So the formula for this is the annual percentage yield, APY, is equal to 1 plus R over M raised to the M minus 1. And this is the one for the compounded quarterly. So it'll be equal to 1 plus the rate was given to us at 7%, so 0.07, and quarterly is 4. That's something you have to know. The quarterly, monthly, semi-annually, you have to know those particular terms. And then it'll be raised to the 4 again, because that's still our M value, and then we're going to subtract 1. And when we put that into the calculator, we will get 0.0719, changing to, moving it over to decimal places, 7.19%. So that is the one with the compounded quarterly. Now the second one said that we were looking for 8% continuously. So for this one, our APY is equal to E to the R minus 1. So it'll be E to the 0.08 because our rate was 8%. And when we put that in the calculator, we will get 0.0833, which will then become 8.33%. So you have two formulas on those. All right, number 17. We are going to look at another problem here. We have guarantee life, or guarantee income life, offered an annuity that pays 6.65% compounded monthly. If $500 is deposited into the annuity every month, how much is in the account after 10 years? How much of this is interest? So we are looking at an annuity. It pays 6.65% compounded monthly, $500 deposited in the account every month. So this is not going to be the A equals P times 1 plus R over N, because we're making a payment every month, $500. We're still looking for what's going to be the account after 10 years, so that's going to be an accumulated value. But in this case, because we're looking at monthly payments, this will be a future value. And then we're going to figure out how much of it is interest. So number 17, our future value formula is a payment multiplied by our 1 plus R over N which is our M, sorry about that, R over M minus 1 divided by our R over M. So now we're going to plug in all the values that we know. So we were told that we were making a $500 payment each month. And then we have 1 plus the rate that we were given was 6.35%. So changing that to a decimal, it becomes 0.0635. So 0.0635. And it's being compounded monthly. So monthly will give us 12. And then from that, we will subtract 1. And then divide by our 0.0635 divided by 12. So when we're putting this into, oh, I left off a part of it. I'm like, something's missing off my formula. All right, we forgot the M and the T. Sorry about that. I'm like, it looks something is wrong. Somehow it got erased. So the M, again, was 12, and the amount of time, I'm like, looks like something's missing, but we're all good. The amount of time was 10 years, so it'll be 10 up on that top part there. Sorry about that. All right, because I'm like, otherwise the ones are going to just kind of cancel each other out, so it wasn't making sense in my mind. Now, when we put this in the calculator, you have to make sure you're treating everything prospectively. So, on the top, you have to put this whole part up here in parentheses. If you don't, then it won't follow the rules of PEMDAS. So make sure you parenthesize the whole thing. Otherwise, when you do the minus 1 and then you hit the divide button, the minus 1 will get multiplied by that. And you don't want that. So you want to make sure that you put it in parentheses. So we'll put this into the calculator together. So we're going to have 500, parenthesis for the red one, parenthesis, 1 plus 0.0635 divided by 12, close this parenthesis, raised to the 12 times 10, bring it back down, minus 1, close the red parenthesis, and then divide by the parenthesis of 0.0635 divided by 12. And we should get, let me make sure. All right, so I wrote down the wrong interest rate. I looked at number 18. All righty, so this should be a 6, and I'm changing this because of my students, because they're like, wait a minute, Miss Stewart. That was 6.65. I was looking at number 18 at the same time there. All right, so I'm like, that's not the right answer, so let's try this again. 500, parenthesis, parenthesis, 1 plus 0.0635 0.065, divide by 12, close the parenthesis, raised to the 12 times 10, bring it back down, minus 1, close that red parenthesis, divide by parenthesis 0.0665, divide by 12. And that's the answer we should be getting. Sorry about that. This is why we give partial credit on exams, is because we make mistakes as well. Rounding it to the second decimal place, we will get 0.40 at the end. All right. Let's go look at we also had to find out how much interest. So when we're looking at how much interest is earned, or how much interest, or how much of this is interest, we're going to take our original amount, or not our original, our accumulated, our future value, and we need to subtract out how much money we paid in. Well, how do we figure out that? Well, we made 500 payments. We made them monthly, and we made them for 10 years. So if we multiply 500 times 12 months of payments for 10 years, we will get $60,000 is how much we paid in. So we subtract out our $60,000 and we end up with $24,895.40. This is how much interest, and this is the accumulated value, the future value. All right, let's go on to number 18. And on number 18, we will use that 6.35% interest rate. So Sun America recently offered an annuity that pays 6.35% compounded monthly. What equal monthly deposit should be made into this annuity in order to have $200,000 in 15 years? So this tells us we're looking for the monthly deposit. Well, that's our payment. So, and we're looking at a future value. So that payment is going to be, payment equals to the R over M times our future value divided by 1 plus R over M raised to the M times T minus 1. So that's our formula that we'll use for this one. All right, so our payment will be equal to our interest rate. We've already looked at this one. We had 6.35%, which will get us 0.0635. So that's our interest rate. Divided by our M. In this case, it's a monthly, compounded monthly, so that'll be 12. And the future value that we're looking for is that 200,000. Then we're going to divide by 1 plus 0.0635 divided by 12 raised to the 12, and the amount of time they're saying is 15 years, and then minus 1. So again, we have to follow our PEMDAS, so we're going to have to parenthesize this whole denominator with those extra parentheses. The multiplication, it'll follow the multiplication, and then division, so it'll be okay. All right, so let's see if I can get this in the screen so you can see it pop in. So we've got parenthesis 0.0635 divided by 12 times 200. Make sure you get all your zeros in there. and then divide by parenthesis, parenthesis, 1 plus 0.0635, divide by 12, close that parenthesis, raise it to the 12 times 15, bring it back down, minus 1, close your last parenthesis there. And we should get a payment of $667.43. So on this, those extra parentheses are super, super important. All right, we are on to number 19. So on number 19, we have an e-loan. Is an online lending service recently offered 36-month auto loans at 7.56% compounded monthly to applicants with good credit ratings. If you have a good credit rating and can afford monthly payments of $350, how much can you borrow from e-loan? What is the total interest you will pay for the loan? So you're looking at how much you can borrow now, because that's what you're trying to do here. You're looking at the now part, the present part, so you're looking at a present value. And we are given a payment. We're given some time. We're given a percentage rate. And we are told that it's compounded monthly. So in this case, the formula that we're looking for is that present value is equal to the payment times, we'll have 1 minus 1 plus r over m raised to the negative m all over r over m. So we're going to have some added parentheses in here as well. All right, so our payment is $350, getting multiplied by 1 minus 1 plus, the rate was 7.56%, so that'll get a 0.0756. And it's being compounded monthly and then raised to the negative of how long that's happening. All right, we're going to come back to that here in a second. And then we'll be dividing by 0.0756 divided by our 12. And we've got to do that negative exponent. And I want to make sure we have the correct formula here. I just want to double check and make sure we've got the right formula. And there should be a T sitting here. All right. I guess I made my notes a little too fast. I'm like, there should be a time there. All right, so M and T. So our M is our monthly, which will be 12, and the T is time. Now, it has to be in years. So we were given 36 months. If we divide that by 12, we will get 3 years. So our T will be equal to 3. All right. So that's our whole part there. What we really worry about here, again, is on that top, we've got to have those parentheses. And then on the bottom, we also need to make sure we parenthesize that whole thing. All right, so let's go put this in our calculator. Let's clear that out. So we have 350 parenthesis 1 minus parenthesis 1 plus 0.0756 divide by 12, close the parenthesis, raise it to the power of, to do your negative, you got to use the little negative guy down here. So negative, you can't use the minus sign, 12 times 3, bring it back down, and then do your next parenthesis, that is the red one right here. And then divide by parenthesis 0.0756 divide by 12. Close that parenthesis. And we will get $11,241.81. That 8 after the 0 will cause it to raise up. So $11,241.81. That's how much you can borrow from the loan, the e-loan, in order to buy a car. So that's the price of the car that you can get the loan for. And you've got to allow for, whatever additives they're putting into the loan. But that's the present value you can borrow. All right. And on this test, you will be given, in my class, the formulas. And they will be complete formulas, unlike my notes here. All righty. So let's go look at number 20. This is our last problem. So you want to purchase a sailboat for $28,500. The dealer offers you 0% financing for 60 months or a $6,000 rebate. You can obtain 6.2% financing for 60 months at the local bank. Which option should you choose? All right, so you've got a couple of options here. You're looking at the value of it, the present value you're given here. And the dealer offers you 0% financing for 60 months, or you can get a $6,000 rebate. So you have to take that rebate into account when we're doing the price here. You can get financing for 6.2% for 60 months, or you can choose to take the 0% for 60. So we've got two parts that we're going to have to work out. First of all, we are figuring out what the payment is. We're given what the present value is, so we're looking for the payments. And we're going to compare one payment to the other payment. All right. So our formula for this one will be the payment is equal to the present value times the R over M divided by 1 minus 1 plus R over M raised to the negative MT. And we'll look at what all formulas we need to put into this. Or not formulas, but parentheses. So the present value that we are given, we have to pay attention to which part we're working here. If we are doing the rebate, the initial price that we are told is $28,500. And then if we subtract out $6,000, that gets us $22,500 that we are actually looking to borrow. So we're not going to use the $28,500 here. We're going to use $22,500 because they're giving us a rebate, so that'll lower down how much we're actually going to borrow. So $22,500. Our interest rate was we have 6.2%, which will become 0.062. So we have 0.062, and we are told that it is compounded, it'll be monthly. All right. And then we are going to divide this by 1 minus 1 plus 0.062 divided by 12 raised to the negative 12, and t is the amount of time. We were told 60 months divided by 12 months gets us 5 years. So this will be times 5. Now, again, we have to add in the parentheses down here so that we have the whole thing at the bottom. Otherwise, we'll divide by 1 and then subtract all of that. All right, so let's go put this in our calculator again. So we have 22,500. Let's clear all that out. 22,500, parenthesis, 0.062 divided by 12, close that parenthesis, divide by, parenthesis 1 minus, parenthesis 1 plus, 0.062 divide by 12, close the parenthesis, raise it to that negative 12 times 5, bring down your parenthesis and or bring it down to put in that last parenthesis. And we'll get $437.08. All right, now we have to decide, this is the rebate offer. Now, if we don't do the rebate, we get 0%. So this was the rebate. If we look at the 0%, we want to figure out our payments. Well, the original borrowing part is $28,500. We're going to make 60-month payments, right? 60 months. So we'll divide by 60, and that'll get us $475. So which payment do we choose? We have a payment here at $437.08 and a payment here of $475. Same amount of time. Well, we're going to choose the rebate because we will actually pay less for our car than we will here. So we are going to choose the rebate because the payment will be less.